Hi everyone, in this video we're going to be working through an exam question involving composite functions. Now, as you know, to make a composite function we need two functions. And the whole idea behind this exam question is that one of those two functions is unknown. And as we're about to see, here we're given the composite function, and our job or our task is to figure out what the unknown function is. And so here's the whole idea. We're told, given f of x equals to ax plus b and g of x equals to x squared plus 3x minus 10, find the two possible functions f of x such that g of f of x equals to 4x squared plus 2x minus 12. Now if you're up for it, go ahead and press pause and try solving this on your own, and if not, let's get started. So I'll start by moving this question to the side, like so. And as I always do, I'll quickly write SOL here for solution. Now here we're told that g of f of x equals to 4x squared plus 2x minus 12. And another way I could write that is to say g of f of x like this. G of f of x equals to 4x squared plus 2x minus 12. Furthermore, since f of x is equal to ax plus b, we see that here. And since g of x equals to x squared plus 3x minus 10, we could also write an expression for g of f of x involving the unknown coefficients a and b. And that would look something like this. I could write g of f of x, there we go, is equal to, well, the expression I'd obtain by replacing every x I see inside g by f of x. In other words, by ax plus b. So I'll do that in steps here. I'll start by saying g of f of x is equal to f of x in parentheses squared plus 3 times f of x minus 10. I carry on and I now replace the f of x's I have here by the expression ax plus b. So this would turn into ax plus b in parentheses squared plus 3 times ax plus b in parentheses minus 10. I carry on and I open up these parentheses, and so for this first one, ax plus b squared, I use the formula a plus b in parentheses squared, which equals to a squared plus 2ab plus b squared, so that this turns into a squared x squared plus 2 times ab times x plus b squared. And I carry on and I distribute this 3 across this pair of parentheses. And that leads to 3 times ax, so 3ax, plus 3b, and of course we have our minus 10 at the end here. Okay, now that I've expanded everything, the idea here is to gather like terms. And so let's see, I can see that I only have one x squared term, so that's equal to a squared x squared. And I can see that we have two terms involving just x, there they are. And so I can now say that's plus 2ab times x plus 3ax. And last but not least, we have all these constant terms here, so that's plus b squared plus 3b minus 10. In other words, those are the terms that don't involve x. We'll just write those at the end here, plus b squared plus 3b minus 10. Now, although we don't know what a and b have to equal to, what we do know is that this entire expression here needs to be equal to 4x squared plus 2x minus 12, since that's the composite function we were given at the start. And so to make things a little bit more obvious, what I'll do here is I'll place an x as a factor for these two terms involving x here. Here's what I mean. I'll go ahead and write that this is equal to a squared times x squared plus, in parentheses, 2ab plus 3a, close parentheses, times x, plus b squared plus 3b minus 10. And that's the expression we get for g of f of x. There we go. Now, here comes the important part. Since we know that this composite function needs to equal to 4x squared plus 2x minus 12, that tells us that this entire quadratic expression here needs to equal to the one we have here. And that provides us with a method for finding the coefficients a and b, and therefore provides us with a method for finding the unknown function f of x. And here's the whole idea. To find a and b, we equate the coefficients of the various x terms we have. In other words, this a squared here, which is multiplying x squared, needs to equal to the 4 that's multiplying the x squared we have here. Similarly, this 2ab plus 3a, which is multiplying the x in this expression, needs to be equal to the 2 that's multiplying the x in this one. And last but not least, this b squared plus 3b minus 10 must be equal to this negative 12 we see here. So let's go ahead and do this. I'll start with the a squared that's multiplying the x squared here. And I'll do all of this in the top right hand corner here, and I'll say equating powers, or actually I'll say equating like powers of x. There we go. And I'll go ahead and underline that. So we have, let's see, we just said a squared, which needs to equal to 4. Again, I'm getting that from the leading coefficient here and here. And so if a squared equals to 4, that means that a will equal to plus or minus the square root of 4. In other words, a is equal to plus or minus 2. And I'll go ahead and box that intermediate result there. There we go. Now, depending upon whether a is equal to plus 2 or minus 2, well, we're going to get a different value for b. So we need to consider both separately. And so I'll start with the case if a equals to negative 2. Well, let's see, we know for a fact that 2ab plus 3a has to be equal to 2, right? So let me just write that out. I know that 2ab plus 3a has to equal to 2. But of course, if a is equal to negative 2, then the expression on the left-hand side here will turn into 2 times negative 2 times b plus 3 times negative 2 equals to 2. I now tidy this left-hand side up a bit. 2 times negative 2 is negative 4, so we have negative 4b. And I'll quickly write that. That's negative 4b plus 3 times negative 2, so that's plus negative 6. In other words, we have negative 4b minus 6, which equals to 2. Now, solving this equation for b, I add 6 to both sides, which quickly leads us to negative 4b equals to 2 plus 6, which is 8. And finally, dividing both sides by negative 4, we quickly obtain b equals to 8 divided by negative 4, which is negative 2. And we're done. If a equals to negative 2, then b must also equal to negative 2. And so in theory, that's one of the 2 possibilities. I carry on here, and in fact I'll split my working in 2 like so. If, on the other hand, a is equal to positive 2, so simply if a equals to 2, then in that case, this 2ab plus 3a, which has to equal to 2, well, let's see what it becomes then. We'll still have, of course, 2ab plus 3a equals to 2. And so replacing the 2 a's we see here by 2, it becomes 2 times 2b plus 3 times 2 equals to 2. And 2 times 2b, well, that's 4b plus 3 times 2, which is 6, and that's equal to 2. And now solving this by subtracting 6 from both sides quickly leads to 4b equals to 2 minus 6, which is negative 4. And finally, dividing both sides of this equation by 4, we obtain b, which is b equals to negative 4 divided by 4, which is negative 1. And that's the other possibility. If a equals to 2, then b would have to equal to negative 1. And so going back to the fact that f of x equals to ax plus b, this first possibility here would mean that f of x equals to negative 2x minus 2. And the second possibility we just found here would mean that f of x is equal to 2x minus 1. And those are the 2 solutions. Indeed, provided f of x equals to either negative 2x minus 2 or 2x minus 1, then g of f of x will equal to 4x squared plus 2x minus 12. And as such, we're done. But let me finish this video by showing you what we could do with this b squared plus 3b minus 10, which has to equal to the negative 12 we have here. And as you're about to see, that equation for b will in fact just confirm the 2 results we just found. So let's quickly look at that, and I'll just do that here. I'll make a bit of space. There we go. We know that b squared plus 3b minus 10 has to equal to negative 12. So let's quickly write that out. We have b squared plus 3b minus 10, which has to equal to negative 12. And so gathering all of the terms on the left-hand side here, which I do by adding 12 to both sides, this quickly turns into b squared plus 3b plus 2 equals to 0. And as such, we're now faced with a quadratic equation for b. And we could solve this using the quadratic formula, of course, but we could also solve this by factoring. And since the leading coefficient here is 1, indeed we have 1b squared, we can factor this by quickly looking for 2 numbers which add up to 3 and whose product is 2. And so the numbers 2 and 1 definitely work. And we can state that this is the same thing as b plus 2 times b plus 1, which equals to 0. And for this to equal to 0, either b plus 2 equals 0 or b plus 1 equals 0. And so let's quickly write that out here. If b plus 2 equals 0, then b equals to negative 2. And of course, if b plus 1 equals to 0, then b would equal to negative 1. And these two results for b confirm the two results we had just found a few minutes ago. So if you're in the exam room and you find these two results following the ones you found here, well, you can leave that question knowing you got the correct values. And there we have it. There we go, everyone. I really hope that helped, and if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said, that's it for this exam question on composite functions with an unknown function.